Okay, let's look at this last problem. This is problem 5 in the problem sheet. And what we've been told is that each of these NOT gates have a delay of 1 microsecond. Okay, so let's say my input, and let's say my input is it's a signal of 1 hertz. So let's say the input looks like this. Okay, and then again it becomes high, and it goes on like that, isn't it? Or maybe what we should do is we should just make it a little bit smaller so that we can, okay, let's do it this way so that we can see a full or 2 cycles of the input. So that's your input, which is in this case called DG1. Okay, so that's the that's the input to this AND gate at this point, or as well. So 1. Now what's the input at the second point here? Now we've been told that each of these NOT gates give us a 1 microsecond delay. What does that mean? What that means is that the output, let's say, of the first gate is going to be 1 initially, and then it's not going to shift exactly at this point, but it's going to shift after a particular delay, right? And this time is going to be 1 microsecond, right? And then the shift here also is going to take 1 microsecond, so that time is also 1 microsecond, and similar, and so on and so forth. So you'll have a 1 microsecond delay here as well, and a 1 microsecond delay here as well. Now we have 3 NOT gates, which means the delay is not going to be 1 microsecond, but it's going to be 3 microseconds. So let me change this to 3 microseconds. 3 microseconds, here there's a 3 microsecond delay, and if we write this time here, that is again 3 microseconds, and the delay here again is 3 microseconds. Okay, and now what we have is we have an AND gate here which is ANDing both these signals. So what is the output going to be? So initially it's going to be 0, at least till this point it's going to be 0, right? Because DG1 is 0, or this input 1 is 0, 1, and let's call this 2, corresponding to this 1 and this 2. Okay, and then for a brief time, for 3 microseconds, both 1 and 2 are going to be 1. So we'll have an output of 1, and then 2 becomes 0, so then we have a signal like this. And then again for a brief duration here, what we will have is we will have oh, I'm sorry. So in this case you have 1 and you have 0, so this is just going to be 0 all the time, right? So it's going to continue to be 0. It's not going to change to, I was thinking that there is going to be a change here, but no, this is 0 here, this is 0, 1, 0, so it just remains 0 till this point here, where again the signal becomes 1 and 1 here. So again for a brief duration of time, which is 3 microseconds, it becomes 1, and then it remains 0 like that. Okay, so the pulse width here is 3 microseconds. Now we have a signal which is 1 hertz, which means that the time between this point and this point is 1 second, right? Because that's 1 cycle. So which means that the time between this pulse here and this pulse here is going to be 1 second as well. Oops, I should have drawn the arrows like this. So at the output, we have a small pulse of 3 microsecond at every 1 second, or at 1 hertz, right? At 1 hertz intervals, you have a small pulse which is of width of 3 microseconds. So that's how the output looks like.